Alright, this is chapter 5.4, Solving Inequalities, and we're going to solve them first by adding or subtracting. So here is the key concept for addition property of inequalities, if you could get this copied into your notes, and then replay me for the explanation. So it says, if any number is added to each side of a true inequality, then the resulting inequality is also true. For example, if all numbers a, b, and c for all numbers a, b, and c, the following are true. So the first one is if a is greater than b, then if I add c to both sides, to both a and b, then a plus c is greater than b plus c. Okay, well let me show you that in some numbers. So if I say that 4 is greater than, 4 is greater than 1. Okay, and then I add, let's say 2 to both sides. So I'm going to add 4 plus 2 greater than 1 plus 2. Notice I added 2 to both sides. 4 plus 2 is 6 greater than 3. Okay, so because I add 2 to both sides, the resulting inequality is still going to be true, right? 4 is greater than 1, 6 is greater than 3. Similar to number 2, if a is less than b, then a plus c is less than b plus c. So I add c to both sides. This is also a resulting inequality that is true. So let's say 2 is less than 4. Okay, and I'm going to add 2 to both sides. So I have 2 plus 4 is less than 4 plus 2, right? Plus 4, oops. Yes. 2 is less than 4 plus 2. I'm adding 2 to both sides. And that is 4 is less than 6. Okay, so if I add the same thing to both sides, I'm still going to get resulting inequalities that are true. Okay, here's the subtraction property of inequality. Go ahead and get this copied down, and then I'll explain it. So the subtraction property of inequality states that if any number is subtracted from each side of a true inequality, the resulting inequality is also true. So for the numbers a, b, and c, the following are true. If a is greater than b, then if I subtract c from both sides, then a minus c is still going to be greater than b minus c. Again, let's see, 4 is greater than 1. Let's say if I subtract 1 from both sides, I'm going to say 4 minus 1 is greater than 1 minus 1. 3 is going to still be greater than 0. Okay, so when I subtract the same thing from both sides, I'm still going to get a true inequality. Similar, if I have something like, let's say 1 is less than 4 for this second example, and I subtract 1 from both sides, I'm going to get 1 minus 1 is less than 4 minus 1. Subtract 1 from both sides, I get 0 to be less than 3. Again, 0 is less than 3, so that is a true inequality. Okay, so here are going to be our examples. Solve each inequality, check your solution, then graph the solution on a number line. So the first one is x plus 5 is greater than 12. Now, we're going to solve these just like we would solve them if there were an equal sign. So I'm going to draw my line down the equal, or now it's the inequality symbol. So I'm going to subtract 5 from both sides, because that's what I would do if that was an equal sign. Those cancel, and x becomes greater than 7. Okay, now when I check my solution, this is going to be a little bit different than how we had it before. You actually have to read your inequality in order to find the number that you're going to plug back into your equation. And this says x is greater than 7. So I need something that is greater than 7 in order to plug in. So for example, 8. 8 is greater than 7, so I'm going to plug 8 in for x. So it'll be 8 plus 5 is greater than 12. 8 plus 5 is 13, greater than 12. And then ask yourself, is 13 greater than 12? If it is, then your answer is correct. And then it also asks you to graph the solution on a number line. So we're going to draw our number line. Your number in the middle is 7, 8, 9, 6, 5. This is going to be an open circle on 7. Shade it to the right. All right, give this one a shot. And replay me when you're ready for the answer. So first of all, we're going to subtract 10 from both sides. We get x to be less than -7. And when we're checking, I need a number that is less than -7, so you could choose -8. Plus 10 is less than 3. So I get 2 to be less than 3. 2 is less than 3, so I'm good with that. And my number line, I've got -7, -8, -9, -6, -5. This is going to be an open circle on -7, pointing to the left. Okay, you try this one again, and when you're ready for the answer, go ahead and replay me. So I'm going to subtract 7 from both sides, and I get x to be greater than or equal to +3. And I'm going to choose something that is greater than or equal to 3. So I could actually choose 3 in this case, or I could choose a number that is greater. So I get 11 is greater than or equal to 10, and that is true. Or I could have used a 3 in place of 4, and I would get 10 is greater than or equal to 10, which is also true. So here on the number line, we're going to plot 3, 4, 5, 2, 1. This is going to be a closed circle on 3, pointing to the right. All right. I'm going to do this one. So work this one out as I work it. Work it out on your paper as I work it on the board. So we're going to draw a line down. We're going to subtract 7. And I get -4 is greater than or equal to g. Now, the difference between this one and all of the examples before is the variable is has been on the left. But look at this one. The variable here is on the right. So how I want to get the variable on the left is I'm actually going to switch positions. So my g is going to go first, and my -4 is going to go second. Okay. Now, when I do that, I also want to switch my sign. So I'm going to flip that sign from a greater than to be a less than. And that's all you do. So switch the position of the variable in the number, and then once you switch that, switch your sign. So your variable's on the left. So this reads g is less than or equal to -4. So I want something that is less than or equal to -4, so I could choose 3 is greater than or equal to -5 plus 7. 3 is greater than or equal to +2. That is a true statement. So my answer is correct. So I want to graph on a number line. I get -4, -5, -6, -3, -2. Closed circle on -4, pointing to the left. Okay. All right, so hopefully this part makes sense for you. Go ahead and try this one. It's a little fraction in there. And replay me when you're ready for the answer. So first of all, I'm going to subtract 5 sevenths. All right, in your scratch work, you will see that b is greater than 9 sevenths. So I wanted something that is greater than 9 sevenths to plug in. So I get 10 sevenths plus 5 sevenths is greater than 2. And I get 15 over 7 is greater than 2. And 15 over 7, we know that 14 over 7 is 2, right? So 15 over 7 is going to be a little bit more than 2. And if you change that into a decimal, that really is 2.1 is greater than 2, which is true, right? 2.1 is greater than 2. So I know that my b is greater than 9 sevenths is going to be true as well. Hopefully those fractions didn't trip you up too bad. So here on my graph, I'm going to do 9 over 7. And 9 over 7 is just a tiny bit greater than 1. So your 1 is going to go here, and your 2 is going to go here. Because 9/7 is 1 2/7, right? So it's a little bit more than 1. And this is going to be an open circle in 9/7, shading to the right. All right, if you didn't get this one the whole way through when you're working it yourself, hopefully you understand it a little bit more. And finally, I'd like you to try this one. This one has a fraction and also the variables on the right. So be careful when you're using your fractions and make sure you get that flip in there correct. All right, so first of all, you want to add 1 1/3 to both sides. And you get 4 1/3 is less than or equal to b. Now your b and your 4 1/3 want to switch. And then this less than or equal to is going to change to greater than or equal to. So I want a number that is going to be bigger than 4 1/3 or equal to 4 1/3. And I'm going to choose 5 1/3. So I get 3 is less than or equal to 5 1/3 minus 1 1/3. And 5 1/3 minus 1 1/3 is 4. And I get 3 is less than or equal to 4, which is a true statement. So I'm going to go ahead and graph it on my number line. And on my number line, I'm going to plot 4 1/3. That's a little bit more than 4 and a little bit less than 5. So this is going to be a closed circle on 4 1/3, pointing towards the right. And here are our practice problems. Try these the best you can. We'll go over them first thing next time we see each other. Good luck.